we're going to talk about performance testing, but I'd like to start with performance and why performance is scary and is very, very important, and we should all think about it. Then we'll move through some terminology, discuss what things mean with regards to performance testing, look at principles of performance testing, discuss how Agile and DevOps changes what we need to do, or how we need to performance test. Then looking at what we do at Core Credit, how to recruit a performance tester, and there is a prize. There's a couple of prizes that I can give away, so I'm going to ask for a bit of interaction at certain points. So I'll throw a couple of things into the audience to a couple of the best sort of interactors, if you like. Okay. So yeah, so that's it. So if you don't want to hear that, then please leave now. It's that good. Okay, so performance is scary. So hands up, how many of you have seen this face at work? So I guess you see lots of people, oh my God, Outlook not working, I can't get my emails. What about this person, someone on their mobile phone, Facebook won't load, something like that. So maybe double hands up if you've seen both of those people. Okay, great. So lots of people, yeah, performance is annoying, isn't it? You say your Wi-Fi doesn't work and you just can't get an internet connection. It's frustrating, isn't it? What about this person? A gamer, maybe he's online playing FIFA or Call of Duty or something like that, and he just sees buffering and suddenly scores a goal against him. It's very frustrating, isn't it? And then finally, a child, maybe they're on their iPad or their tablet and the thing won't load. They can't get onto CBeebies or something like that. I think is a popular app we've got in the UK. So yeah, it's just very frustrating performance. I think there was an advertising campaign in the UK about broadband, and you don't know somebody until you've seen them with a really slow broadband connection and sort of pulling their hair out, and that went down pretty well. Okay, so then probably some more relevant performance problems. Obamacare in the US. So in the US they have an insurance-based healthcare system, and Barack Obama tried to introduce something called Obamacare, which was to have more universal healthcare. So they launched this. 4.7 million people tried to log on in 24 hours, and they only managed to service a few thousand of those requests. And it was a massive, massive problem. And that was just simply too many people, bottlenecks. They had performance tested it, and it was a real problem. It took them weeks and weeks and weeks to sort out. Marks and Spencer's in the UK. Does anyone know Marks and Spencer's? So it's, yeah, massive, massive chain. Sells everything, food, clothes. It's the sort of the cornerstone of the high street in the UK. They relaunched their website. It was meant to be massive gains. They were meant to sell lots of stuff. But actually, they relaunched. They had performance problems, and sales slumped 8.1%. So they ended up losing money on that. Google. So everyone knows Google, don't they? Well, yeah, doesn't need any explanation. And a few years ago, they discussed performance, and they said an extra 500 milliseconds of latency costs them around 20% of their search traffic. So some pretty big figures there, because if you can imagine what 20% of Google's traffic is, that's a lot. So again, performance is important. Google rankings. So we all want to be the top on Google, don't we? We all want to be on that first page when you Google whatever keyword it is in our business. And part of that Google ranking is performance. Mobile. So we've all got a mobile phone, I imagine. Everyone's got a mobile phone? Yep, okay. I think that just makes us more sensitive. I think we're less prepared to wait. We want things now. We want things on the go. We are just more sensitive to performance. We're not prepared to wait for our dial-up connection to load up, to squeal at us and everything. We're not prepared for that, are we? User experience. So how many people have got a user experience developer or some sort of user experience in their company? So a few, yeah. And so that is a growing field, isn't it? User experience. The fact that we've got that as a specific job role means that is just growing increasingly important and can be something that's a real advantage for a company or a website. And performance is a massive part of that user experience. You don't want to be one of the people who are pulling their hair out, really frustrated. You want your users to be delighted with your website or your product or your service. And performance is a massive part of that. Conversion rates. So conversion rates is a really, really interesting one. People like Amazon doing one click and this sort of thing. Bringing a larger percentage of your traffic through to, and it's probably more important for online retail, but actually converting someone who comes to your website into a sale, and getting a greater percentage of those people further down the line and selling. Performance seems to be a real key one, and then ultimately money, I think, which is what we're all in this for, aren't we? Companies want to make money. We want to make money. The more we convert, the more we sell, the more money we get as a company. And so this was the point I was alluding to there. Amazon report a 1% increase in revenue for every 100 milliseconds of improvement. And so there's some other interesting things that Amazon are doing to try and speed up. And it's not just the website. So the drones that they're talking about delivering your parcels, it's speed of delivery. One click was a big thing for them a few years back. How can we take away the sort of the thought process in that online retail? One click, yep, done. Very, very fast. Performance is done. You almost don't get time to think. Okay. So now we've established that performance is scary. And you've seen all those faces of frustration. And is very important. Performance testing. So what is performance testing? And I've chosen this picture because people used to ask my partner what I did as a job, and it's very easy to explain what a principal performance tester does. She used to say, I watched graphs, I waited until it went spiky, and then I phoned somebody. And that was my job. So there's lots of graphs on here and spiky information, and this is how I imagine I look like, but it's probably a bit removed from that. But this is where I'd like to ask you guys. So what does performance testing mean to you? We're okay, so performance testing terms then. Does anybody have any performance testing terms? So maybe I'll start us off with stress. So stress testing in relation to performance, and what does that mean? So to me, stress testing is loading a system beyond its usual conditions. So if you have a normal load level of say X hundred connections per second, taking it to 1,000, taking it to 10,000, stressing that system out. So does anybody have any terms that they use in their day-to-day work? Somebody. Okay. So I think the point here is that performance testing is an umbrella term, and there's lots and lots of things that come under performance testing. So we've talked about stress testing, and I think scalability is another important one, and an interesting one. So how does the system scale? So with the advent of cloud, that's another interesting thing. So putting the system under load, and load is a very important term, and we'll discuss that in a minute. Putting that system under load and then slowly ramping that load up and understanding how your system copes with that increase in load over time. Is it simply a CPU bound application, and does CPU just simply creep up and creep up and creep up? And then what happens at the point where we sort of fail, if you like? Spike testing. So that's possibly to simulate some sort of TV advertising campaign. We suddenly we go along our normal hundreds of connections per hour, hundreds of connections per second, and then suddenly there's been this massive TV advertising campaign, and there's just thousands suddenly, a short 2-3 minute interval. Can the system cope with a short burst of performance, of load? I think load is the key. Capacity. If you read a book on continuous delivery, they talk about performance testing as capacity testing. Endurance. So putting a system under load for a period of time. So our systems run in production for months, years, decades, even some sort of systems. So we need to be sure that this system that we've got can just cope with lots and lots of traffic over time. And so there you're looking for things like memory leaks and all that sort of thing. Capacity. Resilience. So resilience is an interesting one in terms of performance testing. So that is more to do with having multiple servers and taking some of those servers out of a pool. And can we cope with disaster? So potentially there's some performance elements in that, but I don't think that's probably a performance sort of term, if you like. But I think it's worth mentioning that. Stability is very, very close to endurance. Failover close to resilience. Speed, volume. Performance regression is an interesting one. With the advent of agile and iterative delivery and simply building on feature sets, then quite often what we're doing is deploying more features on top of an already created system, and so we're looking for performance regression. Have we done something in this release which has caused performance to change? And so I think the key point from that is that the terminology isn't universally agreed. There isn't a massive performance test community out there. There isn't performance testing events that are specifically set up to discuss performance testing. The terminology is very woolly in some areas and needs to be discussed. So I think I'd urge you when you're approaching performance testing to discuss what the true goals of that test that you're going to run. And I think this is my key point from terminology, is that performance testing is not load testing. Load is something that you put on a system. So with stress testing, for example, you're placing a greater than average load. Performance regression, you're probably looking at that live load. Spike, you're looking at a high load for a short period of time. Load to me isn't performance testing. Load is the work that we're putting on that system. Load is these guys sitting on this plane. And obviously that's some sort of stress test, I would have thought, of that plane. This is a picture of a cute dog with too much food. So this is an opportunity for me to discuss waterfall, agile, continuous delivery, and how this changes how we need to performance test. So maybe if we were using a waterfall method, then we would performance test at the end of a project. So it would go through business analysis, then it would go through development, then it would get handed over to test. It would be late from development, because it's always late from development. Then test would be late, then performance test would be right at the end. So you're up against a deadline. They're saying, oh, do this performance testing. You put in your estimate 5 days or 10 days or whatever, and suddenly it comes to performance test right at the end. All these other things have been late, and we've got 2 days to look at it in terms of performance on a pre-production environment that really doesn't represent live, that can just be up and down, and it is really tough to understand. And why the hell did we do that? That just sounds stupid, doesn't it? Yeah, and performance, unlike functional testing, doesn't tend to be, if there's a problem, doesn't tend to be a simple 1 or 2 line fix. So how many of you have experienced performance problems? Brilliant. Great. So how many of those performance problems were very quickly fixed, like half a day or something like that? So like 1. Pretty much you put your hand up for we've had performance problems, and this gentleman is amazing at fixing performance problems. The rest of you are terrible. So why the hell are we leaving performance at the end? It's very, very complex. When we find a performance problem, it really isn't like those functional changes where maybe it's 1, 2 lines of code. It is digging around. The analysis required to look at a performance problem alone is a lot of work. So with the advent of Agile, moving to that iterative delivery, then obviously we need more performance testing. We need to do it earlier, and we need to do it more often. And so this is why the dog's here, because he's got in a waterfall method, he would have had his meal maybe at tea time or at dinner, and that would have been it. He would have had to eat his little performance test. But with Agile continuous delivery, he just gets loads of it all the time. So how can this one dog cope with all this food? He can't, I think, is the answer. And so with continuous delivery, we need more and more performance testing. I'm working with a team at the minute, and they've got a cycle time of 30 minutes for some of their software components. How the heck are we going to do performance testing with a cycle time of 30 minutes from source control to production? Okay. So this is where we're talking about early and often and continuous. So we're talking about trends. So continuous performance testing. And Ian, talking later on DevOps, made a good point. He said, what if we do continuous performance testing? Because if we put continuous in front of anything, it makes it sound more like DevOps. And it's right. So I think, yeah, the point here is we can't simply have that end of cycle pre-production performance test. We need to do something earlier. We need to know earlier about what is performance like, even if it's just an indication. We need to know whether we've completely fucked or it's roughly all right. And I think that's the point, is that how do we set up these early and often performance tests to give us that indication of performance? And so these are supposed to be talking about trends in performance testing. And so setting up maybe performance labs or unit tests, even putting it down to that level. How can we put a timer in a unit test and then write that out to a database and then put that on a graph and then put that graph on the wall? If we know the most important parts of our systems, can we make them onto nice visible dashboards? Yeah, early and often continuous. Okay, so other ways to do that. How can we get a complete system earlier? How can we shift left? How can we bring the performance testing effort earlier? Can we do it in smaller units? So we talked about unit testing. So we're talking about making our software more modular, smaller units. We test those small services, all those sort of things that are going on in the industry. Can we stub or can we virtualize to get ourselves a complete system if we haven't got all the components, so that we get that indication of how performance is with the particular component that we're working on at the minute. So this is where it comes back to performance testing is not that scary. It really isn't, and we should all be doing it at every level. This is where I'm asking for your help, really. So I'd like you to go back and do some performance testing. We all need to do it. Everyone is responsible for quality. So that's something we try and live by at Core Credit. Everyone is responsible for quality. So it's not the tester's responsibility right at the end, in their stood by their quality gate going, oh shit, sugar, should I let this through to live? And just wondering, oh, have I ran enough tests? Everyone's responsible. It's a whole team responsibility. And so that then works with performance testing as well. So what can we all do to help performance? How can we think about performance earlier and do that performance testing more often? So, I mean, it's all well and good me saying, just go ahead and do it. This is what you should do. But actually, how the hell are you going to do it? And so one of the ways we've done that at Core Credit is to try and get performance noticed. So we talked about the visible dashboards before, putting some monitoring statistics from live on a dashboard next to the team so that they know a little bit more about what's happening in that production environment. Writing out that unit test and putting a graph of that on a board. Just making performance more visible. And one of the things we put together is a performance testing cube. So these I print off, make them up, and when we get a new tester at Core Credit, I hand one of these to every new tester, and so one of these sits on the desk of everyone. So I'm just going to throw these, not very successfully. So I think it's about having something tactile, something that people are going to notice. Get it noticed. Okay. So we'll run through some of those principles now, the principles of any performance test. So repeatability. When I first joined one company, I was straight from university, didn't know anything about testing. My first job, they handed me performance testing, and we had a graph like this. It was just literally up and down, up and down, up and down, and I couldn't make head nor tail of where performance was at, even if we didn't change anything. So I just couldn't establish a benchmark, and that was actually down to that company had a wireless internet connection. A reasonably small company, and it was my performance was genuinely affected by the weather. If it was rainy, if it was really cloudy, the wireless connection would not be very good, and I was putting so much bandwidth down this connection, I would get slower response times because there was just a network pipe that wasn't big enough. So without repeatability, what is performance? What is performance on any given environment? So focus on repeatability first, I think. Because what are we looking for? We're looking for changes. We're looking for trends in data. If we're doing a continuous or an early and often performance test, we're running this time after time after time after time. And that's where repeatability becomes really important. And then if we're doing that continuous performance test, we're looking for this line here. We've got a little bit of variance, but okay. And we're looking for this big jump, which we're really scared about. And there I'm going, we've got a problem. We need to sort that. And this is a classic example of one of the teams I worked with recently. Going along perfectly, very, very fast. Then suddenly, a developer checks something in, and it went from half a second to a response time of 45 seconds. And because we had that early and often performance test, not on a pre-production environment, on an earlier environment, so a system or an integration test or a performance lab, just a box, we were able to find out about that performance problem much, much earlier, and we were able to say, yeah, we've got a problem, and then they backed it out, and then we worked on that solution a bit, and changed it, and then we put it back in, and then we returned to our normal baseline, and then we all went for a beer. So yeah, that's the value of that continuous test, and without that focus on repeatability, you're going to be the guy up at the top who just doesn't have a clue. So we're talking there about caching. Is there anything that in that performance test that we're adding data to something? So we're talking about clear downs, caching, network connections, anything that can vary. We need to work really, really hard to try and remove that variance. Because typically at Core Credit we talk about in percentage terms about performance rather than response times, and so the smaller we can get that variance, the more we can look at specific percentages, and the more we can tell smaller and smaller changes in performance. Realistic, so it's important for that performance test to be really realistic. I went and talked to a company, and they a massive project, and they had some performance testing consultants came in and blatted the heck out of this system. So they had a TVM, which is a transaction volume model. So that is looking at all of the incoming traffic into the system, trying to create a model of what that is. Our transaction volume model, how many products would you say we had on that? Probably, I would say we maybe have 30, 40, 50 that we could easily add to our transaction volume model. So trying to understand the complete throughput that comes into that system and model it is hard, but I think we need to make that effort to try and make that performance test as realistic as possible. So I went into this company, and they didn't understand the TVM. So they'd spent a lot of time writing this performance test, but actually in terms of load, the load level was way too high. So they were searching for really great performance from this system, but they really didn't need it. The actual projections were much lower than that would ever have. Basically, it wouldn't have got to that load level. So they were almost putting out false information there. Concurrency is an interesting term and probably not well understood, like a lot of the performance terms. We have a lot of discussions about concurrency, and I think it's good to be aware of how your apps work with concurrency. So do you have sticky sessions, and are users actually concurrent, or are they only concurrent while they're performing some action upon the system? Because your concurrency is going to be much less. So a lot of our products are API driven. We don't have a concurrency problem, if you like, because we don't have apps with a lot of users who have sticky sessions and things like that. So concurrency for us isn't much of an issue. The next principle is understand. So I don't think it's okay to, thank you, when you're talking about performance, to simply talk about response times. What you need to do is understand the whole system. So are we talking about looking at how servers are performing? And this is a Nissan GTR, the fastest production car in the world, or very fast. And why I've got this on is because how do you make something fast? So what Nissan do is they monitor everything. There's dashboards everywhere, and you can see everything. You can see tire temperatures, you can see spring densities, you can see all sorts of things. And so if you compare that to something like an Opel Corsa or something like that, I think you've got the speedo, haven't you? And then you've got a fuel gauge. So the principle there is understand, monitor. I think that's how you make things fast. You monitor everything and you speed everything up. You learn more. Understand about the systems from up above and down below. How are you going to affect those systems? Scientific, so this is Albert Einstein. Change only one thing is the important thing here. So if you're testing a new software release, don't change the data. Because if you've changed the software and the data, how do you know which one affected that change in performance? Performance tools. This is Barack Obama, and he's the leader of the free world. And so there's a myriad of performance testing tools there, and I haven't even scratched the surface there. But I'm just going to have a real quick run through of these. LoadRunner, Performance Center, very expensive. Seems to be heavily used in the industry. JMeter. JMeter is why Barack Obama's here, because JMeter is the leader of the free world at the minute. Open source tooling in the performance arena is growing. We're getting lots more tools in there, and they're getting better. JMeter is one I'd ask you to investigate. Grinder, Smart Bear tool set is one we use. It's nice and easy to use. There's a low barrier to entry. Gatling is one we've used based on Scala. Am I right? Based on Scala. MS Load Test. That's a strange one. You have to buy an enterprise edition of TFS for that. If you're just a performance tester, then Microsoft make you buy all the developer tools just to get this one little performance test. So that's a strange one. I've asked them why, and there is no answer, basically. It'd be nice if they'd take that out and just sell us that performance test tool on its own. Neo-load, that's sort of like LoadRunner, but a bit cheaper. WebLoad, Rational, there, some of the bigger tools. Is there anyone in the audience who'd be prepared to shout out what performance tools they use? Great, thanks. So how do you select a tool then? So I've told you you all need to do performance testing, so I assume you're all going to go back to your office and start immediately. How do you select a tool? There's a lot of screwdrivers here. How do you select the screwdriver that is going to be the best? I think you start off, you look at the skills you've got in the team. There's no point in using something like JMeter if you don't know Java, or if you've just got no coding skills. Products. What do your products and services lend themselves to? So maybe don't buy LoadRunner if you're only an API house. Maybe use one of the free tools. Technology culture and the wider dev integration. So if we're promoting everyone doing performance testing, it's something that everyone can buy into. And so Bo talked in the main auditorium about having a common environment. So can we have a common tool for everybody? I don't know. We don't do that at Core Credit. We have multiple tools. So we have one at the enterprise sort of layer, and then we let the teams do their own sort of tooling. They pick the best tool for the job. Cost obviously has an implication. Recruitment. I want you. It's tough. I've tried to hire performance testers for 3 or 4 years. I haven't managed to hire one. I haven't managed to hire one out of the box. I've had to make my own, and so Greta is sat here in the front row. And Greta came from a normal test analyst position, and we identified some traits in Greta that we thought were really good and suitable for performance testing. So yeah, make your own. So I had a chat with a chap called Scott Barber at Test Bash conference in the UK, and he said, I asked him, how do you identify a performance tester? How do you recruit a performance tester? And he said, you've just got to make your own. Look for the person who when the shit hits the fan, when everything's broken, then he's the person you go to, and he fixes it. Application support, could be a tester, could be a dev, could be anybody. He said, look for that really geeky, and when there's a problem, he's the man everyone goes to fix it. He's usually the one who you can turn into a really good performance tester. But I think I'd be a bit wider than that and say, you can turn most people into a performance tester. It's not scary. I think back to the title, it's not scary. So what do we do at Core Credit? This is a picture of our pipeline to live, or our route to live. So we have an idea, it goes to a product team, we do something in version control. We try and version control as much of our stuff as we can. We compile, we deploy, we go into continuous integration, where we do component and unit testing. So can we have a look at performance at those sort of levels? We try and get fast feedback there. We scan it. We use SonarQube, Fortify. We then go to systems and integration, which is a dev and test environment. It's self-service. The teams can spin up their own environments on demand. There we're doing functional exploratory testing. Exploratory testing, if you haven't heard of that, please Google that. That's brilliant. And how can we do exploratory performance testing? So how can we assess the feel there? You're sort of stepping into the user's shoes. How can we understand the user better from a performance point of view? We go to, and as quickly as possible, we get round this loop, and we go to a performance lab. And that is a ring-fenced piece of resource. So the dev and test environments are on cloud. There's a private cloud there that we've got. But the performance labs, again, use the same technology on demand. Teams can spin them up themselves. And then they get a ring-fenced performance lab to deploy the software to regularly. And that's where I'd be looking for the teams to start and try and run that realistic, continuous performance test that just runs all the time. So it just runs all the time, and then the teams are just dropping software on there every half hour, every hour, every day, however long the time for that team is, and then it's just a case of looking at that performance test and going, yeah, it's roughly the same. We'll carry on, and then we carry on round and we go to pre-production, where we try to say, no, you don't do performance testing. So performance testing is dead at pre-production. I don't want you to performance test at all in pre-production. That's quite an evocative statement. But actually, I'm being a bit flippant there. What I want you to do is performance monitoring. And it's that same sort of principle there, that we just want a continuous stream of live throughput on there. And we just want to look for changes. Again, it's trying to inform us about performance. And then we go to live, where we smoke test it and then monitor it on live. And this is what, so monitoring versus testing. So what if we didn't perform? That's quite a mind change, isn't it? Maybe I should say, I don't want you to do any performance testing. I've said you all need to do performance testing, but actually I want you all to do performance monitoring. Pre-production. So how many of you have got pre-production environments? Keep your hand up if you're well, hold on. Put your hand back up again if your pre-production environment is exactly the same as your production environment. You're winning. You are winning. Pre-production is an incredibly complex and expensive thing. What we need to do is try and understand that more by monitoring rather than testing. And I think there's an acceptance that we can't be 100% like that production environment. So that's where we're talking about always-on performance and that stream of live throughput that we could... Testing into... Test your performance. Great.
People to let you do performance testing in production. It's not easy, and I haven't managed it, but I want to. So there's a few things here. My producer's drawing. Can you get a maintenance window? Can you use a maintenance window that you usually use to deploy to actually just build some performance tests? Can you get a knife out and cut a slice of that production environment? So a little about me. So my name's Mounsey. The cube that I've thrown out into the audience, I've got on my LinkedIn profile and SlideShare. So please, LinkedIn, if you're interested in that, print that out and stick that together. It's fun. I like visual thinking, so this is our performance test strategy, if you like. All our test strategies are, and this was an initial version, and I would say it's now a lovely poster that one of the teams has put together. It's in A3 and it's on a board. Making it visual, getting it noticed. And so this shows we don't do a lot of effort at integration and system, but we do a little bit. Then we look at that performance lab, and we spend most of our time performance testing in that performance lab. So we've had those conversations with the business of, oh well, we think it's 10% slower, or we think it's faster. Is that all right? We've had that before we ever get to pre-prod. This is where we do our monitoring. So some further reading then. If you've enjoyed what you've heard, there's a lot of good people out there in the performance testing arena and community now. So this is a slide from Scott Barber. He did a great talk at Test Bash a few years ago. I'd encourage you to watch that. That's free. It's available online, so Google that. Mark Tomlin, James Pulley. There's a lot of interesting discussion out there on the likes of LinkedIn, on Twitter. So please engage with that community and listen to it. I think that's it. So thank you very much, everyone, for indulging me. I'd like to invite questions.
So we have a couple of minutes for questions.
So I have a question. How does it go with continuous delivery? continuous delivery and performance testing. So how do you do that?
Yeah, so I think it goes back to just try.
Let me just go back to the slide where that one, how we do it. So I think for us, continuous delivery is about feedback really, and it's about feedback at every level. So how can we get as fast a feedback as possible? Because we want to go around this pipe as quickly as possible. So these need to be automated and then all feedback and integrated into a system so that we can get some fast feedback on that. And the performance labs, I think, is a really, really important and innovative sort of point there that we've done, giving the teams that dedicated space to deploy to regularly, often, and another sort of check before you get to that maybe multi-team use pre-production environment. So I think it's about making it automated, integrated, and understanding that feedback and making that feedback fast. Because I think that's a massive part of a tester's role, is being an information provider. So how does that performance test provide you with information as quickly as possible? There's some more questions.
At the beginning of the speech, you said that in your first job, the culprit of bad performance was, weather conditions or bad internet connection, to be precise. So how long did it take for you to figure that out, and how did you figure that out?
Okay, so you're asking about the wireless connection when it was just going up and down like this. And so how long did it take me to figure it out? I don't know. I think I was very, very junior. I'd just come out of university at that point. So I wrote a report and took a load of baseline and said, look, it varies all over the place. And we worked through it with some developers, some architects. So we've formed a sort of mini team around it. And I would say it took no more than a week, really, to establish that was the problem and to get us into a nice low variance graph rather than this graph that was like that. So I think you've got to engage a team there. So it's about quality is everyone's responsibility, and performance is everyone's responsibility. So forming a team around those sorts of issues is important, and then engaging with your ops guys as well, because they're part of that team as well, really. And how do you bring them in to understand all those components that maybe even the devs, the architects don't understand? So performance is complex. And there are many sort of hidden. Yeah, performance is complex, and there's a lot of problems with it, and you need a wide range of skills to nail down. And I think that's what we showed by that hand, where you all said, yeah, we've had performance problems, and then one of you went, yeah, it's easy to fix. So I think that's what we learned from that. Thank you.